we execute the following sequence of instructions in a stack: push M, push N, add, push M, push N, push M, pop Y. So these are the sequence of instructions in a stack which you are using. Initially, memory at address M contains 010010 and N contains 000010 and Y contains 000000. So at the end of executing the sequence of instructions, what is the content of the memory at address Y? We need to find out the content of memory at address Y. Here push M indicates usually push the content of memory at address M onto the top of the stack. Pop indicates addition is normally it will perform on the top two elements. Pop, for example, if you take pop Y, the pop Y indicates pop the element from the top of the stack and store it in a memory location at address Y. That is a description of these instructions. So finally, we need to know what is the value, the content of memory at address Y. So here let us see perform the operations. The solutions will be like this. So push M. First we are going to push the M value into the stack. Again push N. Next is add operation. So that after adding, the M plus N value will be there in the stack. And pop M here. Next one is pop M means the content of top of the stack will be popped into the location in memory at address M, so that M will get M plus N now. Again push N. N value also we are going to push, so that onto M plus N, N value push. Always it will push onto the top of the stack. Again push M. M means this M plus N. Already M is updated as M plus N, so that M plus N will be pushed. Again pop Y. So Y contains always M plus N, because the top element only will be popped onto the Y. That is pop operation operand indicated is Y. So that Y is equal to M plus N finally. So that M value is given 010010, N value is given as 000010. Both we have to add. One is 10110. 010100 option 010100. Option A is 010100. So finally we got 010100. Option A is the right option here.
Here in this question, a weighted graph is given and we have to find the weight of the minimal spanning tree for the given graph. In a spanning tree, there should be a path between each and every pair of the vertices. So for the given graph, the spanning tree would be here 4 vertices are given and the minimum spanning tree would be this one. In a spanning tree, there should be path between each and every pair of vertices, and the number of vertices and the number of edges in the spanning tree is n minus 1, where n is the number of vertices. So here the cost of this minimum spanning tree is 1 plus 1 plus 1, which is 3 units. So here correct option is option C. This question, xn is given as n power n by n factorial, and we have to find the value of limit n tends to infinity xn plus 1 by xn. So we can write limit n tends to infinity xn plus 1 by xn as limit n tends to infinity xn plus 1 is nothing but n plus 1 whole power n plus 1 by n plus 1 factorial divided by xn. xn is nothing but n power n by n factorial. So if we simplify this, we will be getting it has limit n tends to infinity n plus 1 whole power n plus 1 by n plus 1 factorial into n factorial by n power n. So this is nothing but limit n tends to infinity n plus 1 whole power n plus 1 can be written as n plus 1 whole power n into n plus 1 divided by n plus 1 whole factorial. N plus 1 factorial can be written as n plus 1 into n factorial. So this is nothing but n factorial by n power n. We can cancel this n factorial and n plus 1 n plus 1. So this is nothing but limit n tends to infinity n plus 1 whole power n divided by n power n. So this is nothing but limit n tends to infinity n plus 1 by n whole power n. So if we simplify this, we would be getting as limit n tends to infinity 1 plus 1 by n whole power n. So this is nothing but E. So your correct option is option C.
What is the purpose of page replacement policy? Option A, it decides when a page should be loaded into primary memory. Option A, it decides when a page should be loaded into primary memory. Option B is, it determines which page should be removed from primary memory if all page frames are full. Option C is, it determines how the page should be updated in main memory. Option D, in none of these. So majorly the page replacement policy is meant for, we have to select a victim page for the replacement. For example, if it is a FIFO replacement, whatever the page that is entered into memory first, that page first will be replaced. If it is LRU, least recently used page will be replaced. So the main purpose of the page replacement is, we have to select a victim page for the replacement when the memory is full. In order to insert our faulted page into memory, we have to replace the existing page. So for the selection of which page to be replaced, we have to execute the page replacement policy, so that it determines which page should be removed from primary memory if all page frames are full. Option B is the right option here.
Here f of x is given and initial approximation x naught is given. We have to find the first approximation x1 by using Newton-Raphson method. The iteration formula for Newton-Raphson method is given as xn plus 1 is equal to xn minus f of xn by f dash of xn. So here f of x is equal to x cube minus 2x and f dash x is equal to 3x square minus 2. So here x1 is equal to x naught minus f of x naught by f dash of x naught. Here x naught is given as 2. So this will become 2 minus f of x naught. So here x naught is equal to 2. So if we substitute x naught in f of x, we will be getting f of x naught as 4 and f dash of x naught as 10. So if we simplify this, we would be getting answer as 8 by 5, which is option D. In this question, 3 sorting techniques are given and we have to identify the sorting technique which is in place. A sorting technique is said to be in place if it doesn't use an extra array while sorting the elements. So here insertion sort and quicksort will not use extra array while sorting the elements, whereas merge sort will use extra array while sorting the elements. So here insertion sort and quicksort are in place algorithms. So here the correct option is option D.